practice. All right, I'm going to go over the 7-4 practice A assignment. I've got second hour. I had already started this. I'm starting my video, you guys. Second hour, we started talking about this yesterday, so I have a few things, I have a few things drawn on my paper already that's going to help us get answers for 7-4. I think number one, the first answer, what's the measure of angle AED? AED, we said since this was a rhombus, the diagonals intersect at 90 degrees, so AED would have been 90 degrees. And then ADE, we use the idea that this triangle, and I actually had it highlighted, this triangle's measure is 180 degrees. 180 minus that 90 degree angle minus that 67 degree angle is going to put this one at 23 degrees. We've got the measure of BAE, BAE is 67, because the other thing about rhombus is that the diagonals, excuse me, the diagonals of a rhombus bisect the angles. That's another one of our theorems from 7-4. The diagonals intersect at 90 degrees and they bisect the angles. The length of A to E, I see E to C was 5, so A to E would also be 5. And then B to E is this side of this diagonal, the other side is 12, that would make this one 12. So check out your answers on that. Hopefully you guys did okay there. In number 6, this is about rectangles, and one of our rules about rectangles is that the diagonals are congruent to each other. So I had given you guys the clue to set these equal to each other, solve for x, and then use it. So I'm going to subtract 3 x's from both sides first. So then 4 is equal to 1x minus 1. And then I'm going to add 1 to both sides. 1x is equal to 5. Finish this up. X is 5. And actually, I have to go back and use it. X is 5. 3 times 5 is 15 plus 4 is 19. 4 times 5 is 20 minus 1. These are both 19. Because it says find the lengths of the diagonals. So really, X and then telling me that the diagonals are each 19 was what I needed on 6. That got a little messy over there. I was doing a couple things. A lot of people asked me about number 7. This 3/2 is 1.5. That 3/2 is 1.5. You might want to make a change on that. I think the answer, if I remember right, works out to be 14. If you don't have 14, make sure you pay attention to y. I do believe the x turns out to be 14, I think. Hold on a second here. So this is half of x minus 6 equals 1. When I add 6 to both sides, there we go. Half of x is equal to 7. When I divide 7 by a half, x is 14. But I have to go back and I have to use it. 2 times 14 is 28. 28 minus 6 is 22. 1.5 of 14 is 21 plus 1, 22. The diagonals in that one are both 22. The 8 and 9 problems wanted you just to classify as the most specific. Is it a rectangle, a rhombus, or a square? And give all the names that apply and explain your reasoning. Well, on this one, I would call this a rectangle. And to explain, you have opposite sides congruent. And you also have, all your sides intersect at perpendicular. Sides are all perpendicular to each other. And that speaks to perpendicular to each other. And that speaks to the fact that it's got the 90-degree angles all the way around. You could drop in congruent marks. I saw a couple people do that. Sides are all perpendicular to each other. Just make sure that you're putting enough on your drawing or as an explanation to explain away why we said it was a rectangle, because the definition of a rectangle was opposite sides congruent and 90-degree angles. In number 9, I actually noticed, before I started doing distance formula, I actually noticed that the diagonals of this figure are both 4. When I drew in the diagonals and said that the diagonals were congruent, both of them are equal to 4. I'm going to say that about it. Diagonals are congruent. That went along with, and I'm just looking back in my 7-5 notes right now. if the diagonals are congruent, it's a rectangle, so I know I can call it that. And I've got to give as many names as I can. Diagonals are congruent. Diagonals actually intersect at 90 degrees. So the diagonals are congruent and intersect at 90 degrees. So that means I can call it a rhombus. And then I also need to, because it says give all the names that apply, I think it's a square also. And I'm going to find out if it's a square by doing side lengths. Let's see, the difference in the x's is 3, the difference in the y's is 3. All of the side lengths are going to be 3 squared plus 3 squared under the radical, so all the side lengths are square root of 18. Every single one of these works out to be the square root of 18 for the side lengths, and so I can also call this a square. So I did a lot in that one. I didn't have, I started out by looking at the horizontal vertical lines for the diagonals being congruent. That was a theorem that went along with rectangles. That's why I picked that name. The diagonals intersected at 90 degrees. That was a theorem that went along with rhombuses, so I was able to do that. And then the distance formula told me that all the side lengths were the same, so I could call it a square too. You needed to be able to call it all three. I see a couple of people still writing. But distance formula, like if you go in and use the distance formula on the points, all of these worked out to be root 18, square root of 18. Now, on the back side, determine if this quadrilateral is a rectangle. The only thing we need to do is go back to the rectangle's definition and see if it tells us such. Let's see here. The definition of a rectangle that we have is a parallelogram with 4 right angles. So, is this a rectangle? Go ahead. So the only thing I'm doing when it asks me if it's a rectangle, I'm going back to the definition of a rectangle. Does this figure satisfy a parallelogram with 4 right angles? I can call it a rectangle. I know I could get more specific and call it a square too, but the question is asking me, does it fit this definition? So determine whether the quadrilateral is a rhombus and explain your reasoning. So the definition of a rhombus is a parallelogram with 4 congruent sides. So can I call this a rhombus as well? It has 4 congruent sides. So I know that these aren't the most specific names, but I can still call this, now here's the last one, determine whether it's a square. Well, the definition of a square says 4 congruent sides and 4 right angles. So, yep, because it has 4 congruent sides and 4 right angles. So all I was doing was reading the simple definitions that we started 7-4 with and just seeing if it satisfied it. Now, really, probably the most important thing for you guys to take right here is this is the most specific name. This is the best and most specific name. Now, this next one says, find the measure of angle AEB. Well, since it's a rhombus, these are all right angles. And then find the measure of EAD. Since this is a rhombus, that right angle would be split in 2, so that would be 45 degrees. So, because we said it was a rhombus, we had those 2 rhombus formulas about the diagonals intersecting at 90 and the diagonals bisecting each angle. So that's how I got these 2. Because it was a rhombus, it fit those couple theorems.